So try the warm-up. This is lesson, the second day of 2.4, finding the zeros of polynomial functions. Pause your video, have a go at the warm-up. Okay, let's get over this, get on with this. Question 1 should have is a very quick question. The idea is, if you had a polynomial of degree 4, you would know it have 4 zeros, but what we were looking at yesterday is basically, if we ever have something that's quadratic, that's degree 2, something to do with x squared, x, let's see, then we can always find the zeros of something that's quadratic, either by factoring or using the quadratic formula. However, if something's got a degree other than 2, if it's higher than 2, we're probably going to have to, find some more zeros first to divide out of it until we can bring it down from degree 4 to degree 3 to degree 2, so then we can find the last few zeros. So on this, if this question had said find the actual zeros, we would have had to have guessed and checked to find 2 zeros that we could factor out of this, and then we'd be left with something quadratic to find the last 2. How we would know what to guess and check is what we learned yesterday using the potential zeros theorem, where you find all the p's and divide them by all the q's. Your p's are your factors of 12, so they would be plus or minus 1, 2, 3, 4, 6, and 12. And your q's are all the factors of your leading term, and the factors of 3 are 1 and 3. So our list of all the potential zeros that we could use for guessing and checking would be plus or minus all of the p's divided by 1, 1, 2, 3, 4, 6, and 12, then all of the p's divided by 3. So we're dividing by this 1, then dividing by the 3. And we don't write down any repeats. So we have 1 divided by 3, 2 divided by 3, 3 divided by 3 we won't bother writing because that would be 1 and we already have that here. 4 divided by 3, we need to write that. Come on board, my board's dying on me. 4 divided by 3. 6 divided by 3 would be 2, so we're not going to bother writing that. And then we'd have 12 divided by 3, which would be 4, so we're not going to write that one either. I don't know why my mouse is in the middle of the screen suddenly. I'll move that out of the way. So that was the first question, should have been very quick. This second question is a much longer question. Find all the zeros, actually find them, not just list what are possibilities for rational zeros. Find all the zeros given to. Okay, so we've been, normally this is a polynomial of degree 4, so it has 4 zeros. And we would need to know 2 of them that we could divide out to be left with something quadratic, x squared, to find the last 2. Now, so often we would have had to guess and check to find those, but it would have been very nice. We've been given 2. It's a good job we've given that half. Probably would have taken a while to find that one. So we don't have to guess and check. We've been given 2. We have been given that x equals a half is a factor, is a 0, and that x equals negative 2 is a 0. So what we're going to do is we're going to get our f of x, and we're going to divide out these as factors. So the factor, don't forget, is the 0, is x minus the 0. So the x minus a half would be the factor I'm going to divide out for that. And this one I'm going to be dividing out by the factor x minus minus 2, which is x plus 2. So what I'm going to do, this is my plan of what I'm going to do. F of x is of degree 4. If I divide out x minus a half, I'll have something of degree 3. Then if I divide out by x plus 2, I'll have something of degree 2. I'll be left with a quotient that is quadratic, be something of the form ax squared plus bx plus c, and I can always find the zeros of those, either by factoring or by using the quadratic formula. So that's my plan, that's what I'm going to do. Now, so I have a choice. I could I'm going to choose to divide by this one first, just because the other one's a fraction, and I'm thinking, ooh, I don't want to do that. So the first thing I'm going to do is, I'm going to use synthetic division, so I'm just going to use the 0 there. Write down these coefficients, 4, 20, 29, 4, and minus 12. Now, I was told it is 0. So my remainder had better be 0. If it's not, I know I've made a mistake, and I just erase what I've done and start again. Bring down your first, multiply it back, add them together, multiply it back. Oh, that would be negative 24. Add them together, multiply it back, add them together, multiply it back, and my 0, negative 12 plus 12 is 0, and my remainder is 0. I'm happy, that worked. So what I've done at this point is I have got f of x, and I've divided by x plus 2. I've done this bit. Now I want to try dividing by x minus a half. I'm going to divide this quotient I've got. I'm going to carry on, and I'm going to divide that now. Now I'm going to be dividing what I have in green, dividing by x minus a half. So I'm going to do it with synthetic division, put the 0 here, bring down the 4. 4 times a half is 2. 12 plus 2 is 14. 4, multiply it back. 14 times a half is 7. Add them together. 5 plus 7 is 12. Half of 12 is 6. And I'm happy, because my remainder is 0 again. And it should have been, because I was told that x equals a half was a 0. So what I've done at this point, that's my quotient. I have taken f of x, and I did it in the wrong order just because I didn't like that half. I divided it by x plus 2, then I divided it by x minus a half, and I've got this answer. Let's move this down a bit. I got the answer that it equals 4. That was x to the power 4, so that was x to the power 3, so this is x squared. 4x squared plus 14x plus 12. Now, anything that's a 0 of this quotient would also be a 0 of f of x. So all I need to do is find the zeros of the quotient. Remember, the quotient is the answer to a division problem. Find the zeros of the quotient. So how to do that? Set it equal to 0. Please write it equals 0, otherwise you look like you don't really understand that. And I can fact that it's quadratic. I can solve that by factoring or using the quadratic formula and factor it. It's got a GCF. I can pull 2 out of all of those. Oops, I'll pull that 2 of the x squared. I have 2x squared. Factoring that to, I'm going to use guess and check. Factors of my first, 2x squared, are obviously going to be 2x and x. And I've got various possibilities to put here to get 6 at the end. Let's think about them. This is guess and check. I could have 1 and 6. And because I've got different beginnings in these factors, I actually have to try it the other way around as well. Then I could have 2 and 3 or 3 and 2. All of those possibilities would give me 6. Now just imagine putting them in there. If I put 1 there and 6 there, this gives me 12x plus 1x. No way am I going to get a sum of plus 7x. Not happening. So that was silly. Let's try them the other way around. And as soon as I switch them over and I put 6 here, I know that can't be right, because both of these numbers are even. I would have been able to factor out another 2. I would have had 4 in front there. And this line here did not have a GCF of 4. So I can't put anything that's even in that first parentheses. So not only at this point am I rejecting this choice, I'm also rejecting this one, because 2 couldn't go there either. Okay? Now you do all this thinking in your head, and it's much quicker when you're just doing it in your head. Honestly, it really is. So my only choice is 3 and 2. Check it. 3x, 4x, add them, and I do get plus 7x, okay? If they've both got plus in front of them. So what was I trying to do with this? I was trying to find the zeros. We've got a product of zeros, so one of these factors must be 0. Either 2 equals 0, 2x plus 3 equals 0, or x plus 2 equals 0. Well, one of those lines is obviously rubbish. It's that one. It's not true. This could be true if x was negative 3 over 2. Solving this one would give me x is negative 2. So I found the remaining two zeros. If you look back at the problem, it said find all the zeros of f of x, given the zeros x equals a half and x equals negative 2, then write in fully factored form. So let's first of all write out all our zeros. There's a degree 4. So the 4 zeros of f of x are x equals the 2 they gave us, 1/2, x equals negative 2, and the 2 we found. X equals negative 3 over 2, and x equals negative 2 again. So what we've actually got, there are 4 zeros, but one of them repeats. This one repeats. It has multiplicity of 2. On a graph, at that 0, it's a real 0, so it would have an x-intercept. At negative 2, the graph would bounce. I don't know if it's coming from above and going up, or coming from below and going down. It would be one of those, okay? So we actually only have 3 distinct real zeros, because one of them, distinct, means different from others. Now we have to write this in factored form. So in factored form, f of x equals, okay, we've got it in factored form here after dividing out x plus 2 and x minus a half. So we need these factors and x plus 2 and x minus a half. So it's 2 times, oh, I can't even remember what those were, 2x plus 3, x plus 2, that was the quotient after dividing out x plus 2 and x minus a half. Okay, so that obviously needs to be cleaned up a bit and simplified. First of all, this part here is obviously x plus 2 squared, would be a better way of writing that. Now, we also want to distribute that 2. When you're multiplying, you don't distribute the 2, don't multiply everything by the 2. That would be like saying 2 times 3 times 6, you multiply both of them by 2. That's not right. You don't distribute over multiplication, only over addition. So I want to multiply only one of those factors by 2, and I'm definitely going to choose to do this one, because that'll get rid of my half. So f of x fully factored is 2x plus 3. I've got x plus 2 with multiplicity of 2. It's squared. It's been multiplied by itself. And then after distributing the 2 to the last one, I'd have 2 times x minus 2 over 2, which is like minus 1. Okay? So that's it in fully factored form. So that was our warm-up. Let's do some more of the lesson now.